Hi, Chris Good here. Here's a solution to problem number 4 from our 3530 practice 2 different kinds of t-tests. And this sheet is posted to the course website. So let's read about this problem and we'll decide which t-test to use. Researchers want to examine the effect of perceived control on health complaints of geriatric patients in a long-term care facility. 30 patients are randomly selected. It doesn't say randomly assigned, it says randomly selected. This has to do with sampling, not with experimental design. So they're randomly selected to participate. Half are given a plant to care for, and half are given a plant, but the care is conducted by the staff. It doesn't say they were randomly assigned to do this, but it looks like it's sort of a true experiment where this is what was manipulated. Who cares for the plant is determined by the researchers, and so this is a true experiment. So either they have control over the plant or different people have no control. You measure health complaints one time from each one of these two groups of different people, and so it should be, the appropriate t-test should be an independent groups t-test, which means we're going to be comparing two sample means. So we'll take the average of everybody who had control over their plant, and we'll take the average of everybody whose plant was cared for by the staff. We're also going to count the number of scores in each group because we're going to need degrees of freedom later on. And just like it says in the problem, 30 patients were selected, half were given a plant to care for, so that's 15 in each group. We can do degrees of freedom now too if you really want to. It's the n minus 1 in each group. And now we can go ahead and proceed with our 5 steps of null hypothesis significance testing, starting with stating the null hypothesis, which in an independent groups design is mu1 minus mu2 is equal to 0. Next is to select alpha, which as usual we're going to go with alpha 0.05. It's going to be a two-tailed test because we have no idea who has greater life satisfaction. We want to allow for both findings, and then we're going to look at a critical value for t, and we need to pool our degrees of freedom. I know it's going to be 14 and 14 is 28 degrees of freedom, and we'll look that up in the t table, just to be sure. I'm going to do df pooled right here, so it's df1 plus df2 equals our pooled degrees of freedom. It is 28, of course. So let's look that up in the t table. So we'll go down in alpha of 0.05, two tails combined, and we'll scroll down here until we get 28. So it's 2.048, except it's not. It's actually plus or minus 2.048 because I said it was two-tailed. So we'll say plus or minus 2.048. That's right. 2.048. Great. Okay. So there's our t-crit. We'll do step 3, which is calculate t, which means we're going to need the pooled variance. We're going to need the estimated standard error, the difference between these two sample means, and we'll need t. In order to get pooled variance, I'm actually going to make some room here so we can do sums of squares for each one. So we'll need to get the deviations, the squared deviations, for each one of these two groups. Those are, of course, deviations of each score from the mean of those scores. If I put dollar signs before the column letter and the row number, I can get those deviations. So each one of these cells has the correct mean. And I'm going to do it over here too. So this deviation is a score minus a sample mean. And do the same thing for these deviations. We'll square each one of these just by raising it to the second power. The same thing over here. Oopsies. Copy that. Paste it in each one of these cells. There we go. Now we can do sums of squares. The sum of the squared deviations for this group is equal to the sum of the deviations we just calculated. And I'm going to copy that, whoopsies, and put it right over here. And that'll be our other sum of squares. Let's just make sure that that's what this formula says. Yep, it sure is. It sums those squared deviations. Those are pretty big. Let's see what our pooled variance is going to be. It's going to be the sum of the squared deviations, and you have to put this in parentheses. Both of these, this addition has to be in parentheses before you divide it by the sum of the degrees of freedom. That's df1 plus df2. And your equation's got to look like this. If you deviate from this at all, you're going to be dividing in the wrong order. You got to add first, add second, divide third. So that's our pooled variance. That's a lot of decimals. You can always like reduce those if decimals scare you. Now to get the estimated standard error, it's just the square root equals square root of, and then another set of parentheses. Pooled variance divided by n1. Close that second set of parentheses. We're going to make a third set of parentheses here. Pooled variance divided by n2. Close that parentheses, and then we got to close the square root parentheses. And you notice how it sort of color codes these for you. The internal parentheses are blue, the external parentheses are black. You can zoom in and see those colors. See? Blue on the inside, black on the outside. And that is our estimated standard error, the difference between those two means. T then is simply equal to the difference between mean 1 and mean 2. But I'm going to do that subtraction in parentheses. Mean 1 minus mean 2 divided by estimated standard error. That top part has got to go in parentheses so that Excel does it first before dividing. And look, we get a negative number there because this group had lower life satisfaction than did this group. But is it significant? Well, it turns out negative 3.69 is less than positive 2.048, but it's more negative than negative 2.048. So we're going to, for our step 4, reject the null. And let's write that APA style sentence. Who had a mean of 16.60? Well, that's people who had control over their plant. And who had a mean of 27.07? They had no control. So it looks like, oh, we weren't measuring life satisfaction. What were we measuring? Number of health complaints. That's right. That was from an earlier problem. Number of health complaints. So 27.07. Wow, in 7 days, that's a lot of health complaints. 27.07 if somebody else cared for your plant. 16.6 if you cared for your plant. We should give people plants done. Let's write a sentence. Who are these people? They are geriatric patients. Geriatric patients, given control over a plant, reported significantly fewer health complaints than did those whose plant was cared for by staff. I'm going to press return so that you guys can look at what we've got so far. Geriatric patients given control over plant, that's one level of the independent variable, reported significantly fewer health complaints, so I've got significant and the dependent variable, than did those whose plant was cared for by staff. That's the other level of the independent variable. They're different people, so the experimental design is implicit there as well. All we've got to add is our T, degrees of freedom, and what the observed t-value was, negative 3.69, and the p-value that's associated with it. I have no idea what proportion of area lies beyond negative 3.69 and above positive 3.69, but I know it's smaller than this area that lies below negative 2.048 and above positive 2.048, and I know that that area is equal to 0.05, so that must be less than 0.05. So I'll say P is less than 0.05. And if that was confusing, know this. If you reject, like we did, P must be smaller than alpha. And vice versa. If P is smaller than alpha, then you reject. That is it for this problem. I will see you at the video solution for the next one.